Hi students, good morning all of you. Hope you are all doing good. Welcome to lecture 14 in theory of equations. Hope you have watched the previous 13 lectures in this topic. In this lecture, we will be discussing some problems on transformation of polynomials and we will discuss how to eliminate certain terms in the transformed equation. Before getting into the problems, let us quickly review one of the theorems that we have studied in the last lecture. Here is the statement of the theorem. Let f of x be an nth degree polynomial with a leading coefficient a0 not equal to 0 and alpha 1, alpha 2 and so on up to alpha n be the roots of the equation f of x is equal to 0. Let g of x be the polynomial obtained by replacing root x by x in minus 1 whole to the power n into f of x into f of minus x. Then alpha 1 square, comma alpha 2 square and so on up to alpha n square are the roots of the equation g of x is equal to 0. That is, g of x is equal to f of root x into f of minus root x is equal to 0. That means, if alpha 1, alpha 2, alpha 3 and so on up to alpha n be the roots of a polynomial equation f of x is equal to 0, then the equation whose roots are alpha 1 square, alpha 2 square and so on up to alpha n square is f of root x into f of minus root x is equal to 0. Let us solve a problem based on this result. Here is a problem. Find the polynomial equation whose roots are squares of the roots of x power 4 plus x cube plus 2x square plus x plus 1 is equal to 0. Let us solve this problem. Here is the solution. Solution. Let f of x is equal to x to the power 4 plus x cube plus 2x square plus x plus 1 is equal to 0. Let alpha, comma beta, comma delta, gamma delta be the roots of the equation f of x is equal to 0. Then we know that the equation whose roots are alpha square, comma beta square, comma gamma square, comma delta square is f of root x into f of minus root x is equal to 0. Okay. Let us find out what is my f of root x. That is root x whole to the power 4 plus root x whole cube plus 2 root x whole square plus root x plus 1, that is equal to x square plus x into root x plus 2x plus root x plus 1. Now let us find out f of minus root x. Minus root x whole to the power 4 plus minus root x whole cube plus 2 into minus root x whole square minus root x plus 1 is equal to x square minus x into root x plus 2x minus root x plus 1. Now let us compute f of root x into f of minus root x. f of root x is x square plus 2x plus 1 plus root x into x plus 1. I have rewritten this f of root x in this form. Okay, this has one these are free, these are the terms free from square root, these are the terms containing square root. Now f of minus root x also I will write in the similar way, x square plus 2x plus 1 minus root x into x plus 1. These are the terms free from the square root, these are the terms containing square root. Now if you look at this product, it is of the form a plus b, this is a minus b, so this is equal to what? A square minus b square, so that is equal to x square plus 2x plus 1 whole square minus root x into x plus 1 whole square. Let me expand this in the next page. So f of root x into f of minus root x, that is equal to x square whole square plus 2x whole square plus 1 square plus 2 into x square into 2x plus 2 into bc, that is 2 into 2x into 1 plus 2 into 1 into x square minus root x whole square is x into x square plus 2x plus 1. So that is equal to x to the power 4 plus 4x square plus 1 plus 2 into 2 4 x square into x, that is 4x cube plus 4x plus 2x square minus x cube minus 2x square minus x. Now let us regroup the terms, like terms. X to the power 4, there is only one term. X cube terms, how many are there? 4. I will write it directly. 4x cube minus x cube, that is 3x cube. X square terms, 4x square plus 2x square, that is 6x square minus 2x square, so that becomes 4x square only. Now x term, let us collect. So x term, this is x term, this is one more x term. Yeah, 4x minus x is 3x. Now let us collect the constant terms. You have only one constant term, that is this. So therefore the required transformed equation is x to the power 4 plus 3x cube plus 4x square plus 3x plus 1 is equal to 0. This is the required transformed equation. Let me box this expression. Okay, hope you have understood the problem. Let us solve the next problem. Here is our next problem. Find the polynomial equation whose roots are the squares of the roots of the equation x cube plus 3x square minus 7x plus 6 is equal to 0. Let us solve this problem. Here is the solution. Let f of x is equal to x cube plus 3x square minus 7x plus 6. Okay, let alpha, beta, gamma be the roots of f of x is equal to 0. We know that the equation whose roots are alpha square comma beta square comma gamma square is f of root x into f of minus root x, sorry, this is minus root x is equal to 0. Let me compute f of root x. F of root x is root x whole cube plus 3 into root x whole square minus 7 into root x plus 6. So that is equal to x into root x plus 3x minus 7 root x plus 6. So let us compute now f of minus root x. Minus root x is minus root x whole cube plus 3 into minus root x whole square minus 7 into minus root x. So this is minus root x plus 6, that is equal to minus x root x plus 3x plus 7 into root x plus 6. So this can be written as 3x plus 6 plus root x into x minus 7. This can be written as 3x plus 6 minus plus root x into, let me write the term here, plus root x, if I take common, this is minus x plus 7. Yeah, let us find out f of root x into f of minus root x. Let me write f of root x first. So this is the one, 3x plus 6 plus root x into x minus 7. So this is my f of root x. Let us write f of minus root x. So this is 3x plus 6 plus, now I take common, minus root x into x minus 7. So this is of the form a plus b into a minus b, that is equal to, taking this as a and b, this as a and this as b, it is a square minus b square. So that is 3x plus 6 whole square minus root x whole square into x minus 7 whole square. So this is 9x square plus 36 plus 2 into 3, 6, 6 into 6 is 36. So this is 36x minus x into x square minus 14x plus 49. So that is equal to 9x square plus 36 plus 36x minus x cube plus 14x x square minus 49x. So that is equal to minus x cube plus 9x square plus 14x square is 23x square plus 36x minus 49x, it is minus 13x plus constant term, that is 36. So f of root x into f of minus root x. But actually the required equation is minus 1 whole cube into f of root x into f of minus root x. So that is minus 1 into minus x cube plus 23x square minus 13x plus 36, that is x cube minus 23x square plus 13x plus 36 is equal to 0. Here is the solution for the given problem. Hope you have understood the solution for this. Let us solve one more problem. Here is the problem. Find the polynomial equation whose roots are cubes of the roots of the equation x cube plus 3x square plus 2 is equal to 0. Okay, let us try to solve this problem. Let f of x is equal to x cube plus 3x square plus 2. Okay, let alpha, beta, gamma be the roots of f of x is equal to 0. Then let pi of y is equal to x cube. As for squares we have seen a result, but for cubes there is no result. We will use a general result now. Pi of y is equal to x cube. Okay, then this implies let y is equal to x cube, then this becomes x is equal to y to the power 1 by 3. So this is your pi inverse y. So the required equation is, f of pi inverse x is equal to 0. Okay, so what is f of pi inverse x? F of x to the power 1 by 3, that is x to the power 1 by 3 whole cube plus 3 x to the power 1 by 3 whole square plus 2 is equal to 0. So this is x plus 3 into x to the power 2 by 3 plus 2 is equal to 0. But we want the same cubic equation, but the degree of this equation is only 1. We cannot even say it is 1 because you have a rational power for x. Now we have to separate the terms and cube it in such a way that the powers of x are integers. Now let me do that here. I am separating the terms x plus 2 and this is minus 3 into x to the power 2 by 3. Now in order to eliminate this rational power, what I will do, I will cube on both sides. Cubing on both sides. Cubing on both sides we get x plus 2 whole cube minus 3 into x to the power minus 3 into x to the power 2 by 3. So that is equal to this implies x plus 2 whole cube is x cube plus 2 cube plus 3 into 2 into x plus 2 minus, that is equal to minus 27 into x square. So this implies, let me group the terms, x cube plus 8 plus 6x into x, that is 6x square, 6x into 2, that is 12x, that is equal to minus 27 into x square. This is x cube minus 27 x square. If it comes this side, 27 plus 6, that is 33 x square plus 12x plus 8 is equal to 0. Here is the solution for the given problem. Whenever certain general transformation is given, we have to do the following thing. What we have to do is, we have to assume the given transformation as pi of y, pi of x actually. So this is pi of x. So pi of x is equal to x cube. Now we have to find out the inverse of this transformation. To find out the inverse, what did I do here? Y is equal to x cube I have assumed, then I have found out the inverse of this. X is equal to y to the power 1 by 3, that is equal to pi inverse y. Now pi inverse y is equal to y to the power 1 by 3 is the required inverse in this particular problem, and we know the transformed equation whose root is pi alpha is f of pi inverse x is equal to 0. We have discussed this in the last lecture, so I have substituted the same function, but what we are expecting is, we expect a cubic polynomial, okay, but this is not a cubic polynomial. For that, what I need to do is, I have to separate out the rational powers of x and the integer powers of x, and we have to do certain things. Suppose in this case we have cubed on both sides in order to get the integer powers of x. In the other case, we have to adapt some other methods there, sometimes cubing, sometimes taking power 4 on both sides, taking squares on both sides, all sorts of things you have to do it. Okay, now in this case we have done cubing on both sides in order to get the integer powers. So here is the integer after raising to the power 3, these rational powers of x disappear, then we will get an equation with integer powers. So after cubing it, we will get this particular equation. This is how one can do a problem when a standard transformation is not given. Of course, for all other previous problems we have discussed result. For this particular transformation, no result is being discussed. This problem is being addressed using a general result here. Hope you have understood this problem. Now let me discuss an important theorem called Taylor's theorem for polynomials. Here is the statement of the theorem. Let if f of x be a polynomial function of degree n, then f of x plus h is equal to f of h plus x by 1 factorial into f dash h, that is f dash x evaluated at h, plus x square by 2 factorial into f double dash of x evaluated at h, plus x to the power n divided by n factorial into nth derivative of f evaluated at h, where h belongs to any complex number. Okay, now let us get into the proof of this. Proof: let f of x be an nth degree polynomial as shown here, that is a naught x power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus and so on up to a n minus k x to the power k plus a n minus 1 x to the power 1 plus a n. Now let us compute f of x plus h. F of x plus h, how do we compute? Replace x with x plus h in the above equation. Then we get f of x plus h is equal to a naught into x plus h whole to the power n plus a1 into x plus h whole to the power n minus 1 plus a2 into x plus h whole to the power n minus 2 and so on. A n minus k into x plus h whole to the power k plus a n minus 1 into x plus h plus a n. Now this is going to be again an nth degree polynomial. Let it be f of x plus h is equal to a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 and so on up to a n minus k x to the power k plus a n minus 1 into x plus a n. That means it is precisely this particular thing where we have to find out these coefficients. Okay, now these coefficients are precisely given by this formula. Let us see how do we get that. Okay, replace x with x minus h. What do we get? F of x minus h plus h. That means replacing x with x minus h, we get f of x minus h plus h, that is equal to f of x. That means LHS becomes your f of x. Then RHS becomes what? X is replaced with x minus h. So f of x is equal to a naught into x minus h whole to the power n plus a1 into x minus h whole to the power n minus 1 plus a2 into x minus h whole to the power n minus 2 and so on. A n minus k into x minus h whole to the power k plus a n minus 1 into x to the power x minus h plus a n. Now let us find out the coefficients a0, a1, a2 and so on up to an. Okay. Let this f of x is equal to a0 into x minus h whole to the power n plus a1 into x minus h whole to the power n minus 1 and so on up to a n minus 1 into x minus h plus a n. We call it as equation 1. In this equation we substitute x is equal to h both sides. What do we get? When I substitute h on both sides, then LHS becomes f of h. Then in RHS, this term becomes 0, this term becomes 0, this term becomes 0 and so on, this term becomes 0 and you will be left with only an. This is what we will do now. Put x is equal to h, we get f of h is equal to an. Okay. Now we have found out this an. Now let us find out an minus 1. How do we find out? Let's differentiate equation 1 with respect to x on both sides. What do we get? Let us see. F dash of x is equal to a naught into n into x minus h whole to the power n minus 1 plus a1 into n minus 1 into x minus h whole to the power n minus 2 plus a n minus k into x minus h whole to the power k minus 1 plus a n minus 2 into 1 into x minus h plus a n minus 1 plus differentiation of this constant term is 0. Okay, so now this time you will be having constant term as a n minus 1. Now again you use the same trick, substitute x is equal to h on both sides. So on substituting x is equal to h on both sides, what do we get? F dash of h on LHS, all these terms containing x minus h become 0 and you will be left with a n minus 1. So a n minus 1 is equal to f dash of h. Now let us find out a n minus 2. For that we need to differentiate equation 2. Let us differentiate equation 2 with respect to x on both sides. We get, okay, f double dash of x is equal to a naught into n minus 1 into x minus h whole to the power n minus 2, a1 into n minus 1 and n minus 2 and so on into x minus h whole to the power n minus 3 and so on, plus 2 into 1 into a n minus 2 here. Okay, now if I substitute x is equal to h on both sides, what do I get? all these terms become 0 except this term. So this term is what? 2 into 1 into a n minus 2. So f double dash h is equal to 2 into 1 into a n minus 2 implies a n minus 2 is equal to f double dash of h divided by 2 factorial. In this way, we can find out all the coefficients a0, a1 and so on up to a n minus 3. Let us do that. Let f double dash x is equal to a0 into n into n minus 1 into x minus z all to the power n minus 2, a1 into n minus 1 into n minus 2 into x minus z all to the power n minus 3 and so on 2n into a n minus 2. So differentiate equation 3 with respect to x k minus 2 number of times, then what do we get? So already 2 times differentiated. If k minus 2 times differentiate, then we will get kth derivative of x. Then this is equal to a0 n minus n into n minus 1 into n minus 2 and so on up to n minus of k minus 1 into x minus h all to the power n minus k plus and so on k into k minus 1 and so on up to 2 into 1 into a n minus k x minus h all to the power 0. That means the kth term, if I n minus kth term, if I take n minus k plus 1th term, if I take, the power of x minus h becomes 0. Now you substitute x is equal to h. Then what do we get? Kth derivative of f evaluated at h is equal to k into k minus 1 and so on up to 2 into 1. That is, this is nothing but the k factorial into n minus k a n minus k. Then a n minus k is equal to kth derivative of f evaluated at h divided by k factorial, where k is equal to 0, 1, 2, 3 and so on up to n. Now we have derived a formula for all this k. Now if you vary the k, then accordingly you will get the coefficients. Therefore, substituting all these things in the above equation, what do we get? F of x plus h is equal to f of h plus x divided by 1 factorial into f dash h divided by f dash h plus x square divided by 2 factorial into f double dash at h plus and so on x to the power n divided by n factorial into nth derivative of f evaluated at h actually. Hence, we have proved the Taylor's theorem for polynomial functions. Now, in this slide, we'll start with a question. Here is a question. Which among the following transforms on the root will result in missing of some terms in the transformed equation? Okay. The first one is multiply the roots by k. The second one is reciprocate the roots. And the third one is roots are translated by h. So let us try to answer this question. Okay, suppose let me consider f of x is equal to x square plus ax plus b. Now you have 3 terms in this function. Now let the roots gets multiplied by k. So if these are the roots alpha comma beta, then k alpha comma k beta are the roots of f of x by k. This we have seen it actually. So this becomes x by k whole square plus a into x by k plus b is equal to 0. Now if you can observe that even in the transformed equation also we have 3 terms, and we cannot miss any of these terms. All the terms will be intact. Suppose if at all 3 terms are there in f of x, even in f of x by k also there will be 3 terms. Now, so this is not an answer. Now let us reciprocate the roots. So for the same equation, the roots are 1 by alpha comma 1 by beta. Then in this case the transformed equation is f of 1 by x is equal to 0. Of course, x to the power n into. So then this becomes 1 by x whole square plus a into 1 by x plus b. So this implies we get bx square plus ax plus 1 is equal to 0. Even in this case also you will have the same three terms, not even a single term is being missed. Okay, so even this is not a right answer. So roots gets translated by h, so this means alpha plus h comma beta plus h. So the transformed equation is known to us. What is that? F of x minus h is equal to 0. That is x minus h whole square plus a into x minus h plus b is equal to 0. Here there is a chance that maybe if I choose suitably, the h value will be getting x term here, and suitably manipulate, then there is a chance that some terms can be missing here. That means in this equation I can make some of the coefficients 0 also, whereas in the other two cases you cannot do that. So in order to miss, or in order to make some terms in the transformed equation to be 0, okay, we have to use the transformation called a translation of the roots by h actually. Okay, now let us see how to find transformed equation of a given equation in which certain terms are missing. Okay, given a polynomial f of x of degree n greater than 0, we now discuss a method for finding a complex number h such that for a given k belongs to the set 0, 1, 2, 3 and so on up to n minus 1, the coefficient of kth power of x in the polynomial f of x plus h, which is expressed in powers of x, is 0. Okay, that means what we have to find out is, we have to find out h such that if the roots gets translated by this minus h, okay, in the transformed equation the kth power of x will be missing. Have you understood that? That means you are given a polynomial f of x of degree n. We need to find out h such that if the roots gets translated by that minus h, now we find the transformed equation f of x plus h. In the transformed equation, that kth power of x must not be present. Okay, that means that is our idea of finding h. Hope you have understood what we have to do. Let f of x be a polynomial of degree n. Let me write f of x as this nth degree polynomial a naught x power n plus a1 x to the power n minus 1 and so on up to an. Now we have to find out f of x plus h. So replace x with x plus h in the above equation. We get, of course, roots are translated by minus h and the transformed equation is f of x plus h. So we are finding f of x plus h, a naught, replace x with x plus h in the above equation. We get this particular thing. Now upon expanding it, we will be getting an nth degree polynomial. Upon regrouping the terms, we get an nth degree polynomial. Let me write that as f of x plus h is equal to a1 x to the power n, a2 x to the power n minus 1 and so on up to an x a n plus 1. Call it as equation 1. Now we know by Taylor's theorem for polynomials, this f of x plus h can be written as f of x plus h is equal to x power n by n factorial into nth derivative of f evaluated at h plus n minus x to the power n minus 1 by n minus 1 factorial n minus 1th derivative of f evaluated at h. This is this rth term, and this is last, from the last it is the third one, second term and the last term. That means second last, this is first last, this is second last. Okay, let us try to understand this. This is the first highest term, then x, you concentrate on the power of x, this is x to the power n. Okay, and second highest term is, say, x to the power n minus 1. Now rth highest term means x to the power n minus of r minus 1. So this is the rth highest term in the given polynomial. Okay. Now comparing the two like terms in equation 1 and equation 2, we get ak is equal to n minus k plus 1th derivative of f evaluated at h divided by n minus k plus 1 whole factorial, where k is equal to 1 to 3 and so on up to n comma n plus 1. So to remove the rth highest term in the transformed equation, this ak must be equal to 0. That means ar is equal to n minus r plus 1th derivative of f evaluated at h divided by n minus r plus 1 factorial must be equal to 0. That means h will satisfy this particular equation. In order to find out h, you have to solve this particular equation. Let me highlight this. Examples. Let us try to understand this through examples. To remove the second highest term in the transformed equation. Okay. Then second highest term means what? R is equal to 2 here. So a2 is equal to 0. That is f n minus 2 plus 1. That means second n minus 2 plus 1th derivative of f evaluated at h, that is f n minus 1th derivative of f evaluated at h divided by n minus 1 factorial is equal to 0. That means solving this equation will get h. So if the roots are translated by minus h, then you get the required transformed equation in which the second highest power of x will be 0. Now next one, to remove the third highest term in the transformed equation, you have to substitute r is equal to 3 in order to get that. So upon substituting r is equal to 3 in this, you get n minus 2th derivative of f divided by h divided by n minus 2 factorial must be equal to 0. Okay. Hope you have understood this. To remove the second highest term, that means r is equal to 2, you have to substitute here. Then n minus 1th derivative of f evaluated at h divided by n minus 1 factorial is equal to 0. That is nth minus. That means in order to find that h, you have to solve these two equations for this. For second highest term, you have to solve this equation. To remove the third highest term, we have to solve this particular equation. Hope you have understood this result. Okay. Let us solve a problem based on this concept. Here is the problem. Transform the equation x cube minus 6x square plus 10x minus 3 is equal to 0 into the one in which the coefficient of second highest power of x is 0. That means in the transformed equation, the second highest power should be 0. And also find their transformed equation. Let us see how to go about that. Here is the solution. Let f of x is equal to x cube minus 6x square plus 10x minus 3 is equal to 0. So here n is equal to 3 and r is equal to 2. So in order to remove nth degree, in order to remove rth highest power of x in the transformed equation, the roots must be translated by minus h, where h satisfies the equation f n minus r plus 1 evaluated at h divided by n minus r plus 1 factorial is equal to 0. So here n is equal to 3 and r is equal to 2. Then this becomes f 3 minus 2 plus 1 divided by n minus 2. That means 3 minus 2 plus 1 factorial, that is equal to 3 minus 2 is 1, 1 plus 1. So this is second derivative of f evaluated at h divided by 2 factorial is equal to 0. That means second derivative of f evaluated at h must be 0. Let us find out f dash. F dash x is equal to what? It is 3x square minus 6 into 2 into x plus 10. Okay, that is 3x square minus 12x plus 10. Now what is f double dash x? F double dash x is equal to 6x minus 12 is equal to 0. So now you equate double derivative to be 0, implies 6x minus 12 is equal to 0. Sorry, f double dash at h. Then this becomes 6h minus 12 is equal to 0, implies h is equal to 2. That means roots must be translated by minus 2. Okay, let us continue the problem here. Here is the continuation. That means we have got h value. We have got the h value, that is h is equal to 2. The roots must be translated by minus 2. Okay, the equation whose roots are alpha minus 2, comma beta minus 2, comma gamma minus 2, where alpha comma beta comma gamma are roots of f of x is equal to 0. Okay, the equation whose roots are alpha minus 2, comma beta minus 2, comma gamma minus 2 is f of x plus 2 is equal to 0. This we have seen it earlier. Okay, so we have to find out f of x plus 2. So f of x plus 2 is equal to what? X plus 2 whole cube minus 6x square plus 10x minus 3 is equal to 0. Sorry, I think I have to write it like this: minus 6 into x plus 2 whole square plus 10 into x plus 2 minus 3. So this is x cube plus 2 cube plus 3 into 2 into x into x plus 2 minus 6 into, sorry, yeah, minus 6 into x square plus 4x plus 4 plus 10x plus 20 minus 3. So this is x cube plus 8 plus t into 2 is 6, 6x into x square, that is 6x square, plus 3 into 2 6, 6 into 2 is 12, it is 12x minus 6x square minus 24x minus 24 plus 10x plus 20 minus 3, plus 20 minus 3 is 17. So upon grouping the term, 6x square minus 6x square gets cancelled. Okay, now x terms, if you identify, this is 12x minus 24x plus 10x. So 10 plus 12 is 22, 22 minus 24 is minus 2x. 8 minus 24 is minus 16, minus 16 plus 17 is plus 1. So you can observe that x square coefficient is 0 here, x square coefficient is 0, that is second highest power is 0. This is the required transformed equation. Okay.